Good day, everybody. Hope we have a great day ahead. So today we'll be talking about data mining, a very important subject in data science and machine learning. So when we talk about data mining, before we go into that, let's talk about what mining is in general. Generally, when we talk about mining, in general, we're talking about extraction of precious stones, for instance, or precious materials like gold, for instance. In gold mines, extraction of those materials in the midst of other sources. So you get gold in some areas, but it doesn't look all shining when you get them. They are always dusty and all that. And when you subject those materials to purification processes, heat and other things, then you get shining gold by purifying them basically. So the same thing can be said about data mining in general. So you want to be able to extract useful data from a whole from a whole data set. So in all honesty, when working with data, not everything you receive is important to whatever task you are trying to, whatever analysis you're trying to do. So if you are going to, maybe you're working on trying to determine maybe from a wide range of data what kind of people will be successful. Maybe something like their favorite shirt or their favorite color does not really matter on the grand scheme of things. Yes, what you probably want to be looking for is maybe their work rate, how much they work, their field of study, and all that. But things maybe favorite food or color may not really matter in the general data set. So you don't really want to be able to remove that information and maybe stick to things that are more important. So data mining can be said to be getting useful information from a vast amount of data. By the time useful information, we denote data that can help us predict an output, which is basically what I just said, that not everything you need is important to whatever task you're carrying out. So you want to get the useful information. So useful information is what you need, what can make you make an informed decision, what can make you make an informed analysis or a prediction. So maybe you want to start a business in a particular area, you need to maybe do a lot of analysis. Okay, what's the likelihood? Or okay, I'm trying to sell this, I'm trying to market this in the particular area. Do people really fancy that kind of product in that area? Are people aware of the existence of this product, or and all sort of those? You put those things into account. All right, maybe you are a tech firm, you might want to look at the electricity supply, or maybe closeness to a fuel station and all that, before just moving to a particular area and saying, okay, I want to carry out, I want to start my business here. So we do data mining. We make use of those information, but you don't just, okay, I was trying to start a business somewhere. You might not really want to look at the kind of cars that drive through that area. You know, it might be, okay, you can say, okay, or the number of restaurants in that area may not be the favorite food of the people in that area if you're a tech firm. But for someone that wants to start a restaurant, for instance, it might matter. You get that? Okay, in this area, these people, most of these people like eating this sort of food. There are some areas like that that maybe this kind of people in that area, they eat in a particular range of food. Understand? So you put those things into consideration, but for a tech firm, it may not really matter per se. So generally, so it's about taking out data that is useful to you, that can help you make a conclusive decision that pays you, or make you give you a valid aspect of what you are looking for. So extraction of information is not the only process we need to perform. So data mining also involves other processes like data cleaning, data integration, data transformation, data mining itself, then the pattern evaluation, and data presentation. So once all these processes are over, we'll be able to use this information many applications such as fraud detection, market analysis, product control, science exploration. So we said it's not just about getting the data, you also have to clean the data. When we talk about cleaning, generally we are talking about removing things that are not necessary, removing noise, removing outliers, removing handling missing values, handling several problems that come with data. At times, you might need to move the data from one form to another for it to suit your analysis. Then when you have done all of that, then with what you have done, you get to the pattern evaluation. At the end of data mining, you want to get a pattern. You understand? You want to get a pattern that will help you. So for instance, you might be doing analysis of a company, of how much sales they've made in about 5 years, or the amount of revenue they generate, or the profits they make in the range of 5 years. Then in that range, you want to know, has there been a decline, has there been an increase? You understand? Then if there's an increase, is there a factor behind it? Is there something they did that helped the increase? Or if there's a decline, is there anything? So you want to check, maybe check customer reviews, how much complaints. Did a complain about a particular product to reduce the amount of purchases for that product? You want to do all those analysis, get a pattern. Then the pattern you get, you evaluate it and make a prediction. So you might say, for instance, this product, over 5 years, you've noticed that there has been complaint, and with that complaint, there has been a correlating decrease in its purchase. So what do you want to do? Do you want to stop the sales of that product? Or if you are the manufacturer, do you want to change the manufacturing process? Or you want to stop its manufacturing and move to something more suited to your customers? So you make those decisions after working with data, cleaning the data, transforming data. So you also want to present your data. Your data needs to be presentable. We'll get into all of that as we move on. So yeah, so looking at this data mine, so you can see from this picture, you see a guy just straight into a machine, and everything is just pouring itself in. You have a tablet, a book, and all that. And what comes out there is the text, data, and mining, and all those things. So basically, what we are doing is we are getting a whole chunk of data, irrespective of the source, and we are passing all that into a machine, and the machine processes it. And we get text, we get useful information that is in a format that is understandable. So, which is the goal of data mining. So let's talk about the steps in data mining. Now we've talked about getting data useful to you. So the first step you want to do is select your data. You need to select the right data. For instance, you don't just maybe pick out data. Okay, I want to carry out analysis and just get out data. You need to make use of the right data. Selecting the data you need is a very important step. If you are not making use of the right data, you probably will not get the right analysis. You have to inspect, okay, what sort of information do I need for me to make an informed decision about whatever I'm trying to do? You have to make use of the right data. When you use the right data, you get the proper results. Next step is, okay, after selecting data, you want to clean up the data. So for instance, when we talk about removing noise in data, it's almost like you're saying a purification method in code. You understand? So you have the useful information, you have the information you need, you need to clean it up. So sometimes, for instance, and the one challenge we have is missing values, if you put it that way. When you talk about missing values, maybe you have a row, then a particular cell is not filled. So what do you want to do? Do you want to get rid of that entire row, or you want to maybe fix in an average or a more frequent value, depending on how it looks like. At times, the format of the data may not be too convenient for your data analysis. Do you want to convert it? Do you want to do subject your analysis to those processes? So the next thing is data integration. So what is data integration? So you want to combine data from multiple sources to create unified sets of information for both operational analytical uses. So let's play around that already. So at times you need multiple information. So let's say you are doing some kind of research on maybe how people use the product. For instance, you might want to get information about the user itself or your client itself, his name, is all that. We do that maybe in banking and all that. So you want to get information about your customer, then relate it to maybe a particular product deal, or maybe his um, customer service, for instance. So at times you need to make use of multiple data, to combine them together and make unified sets of information. So in those cases, data cleaning is very important, because getting data from different sources might be in conflicting formats. So you want to make sure they are compatible, then combine them together so that you can make a clean and a unified data that you can work on. So another thing that you want to talk about is data transformation. Now in data mining, it's used in data mining to combine unstructured and structured data for analysis. We just talked about that. When you're getting data from different sources, at times one is structured, one is not structured, one is orderly, one is not orderly. So you want to make sure you combine them to a format that is workable with. So at times when you have those two ranges of data, you're like, okay, what do I want to do? What you need to do is transform. You want to transform, you want to make some kind of correlation. So we do it at times in data analysis. For instance, you are having maybe you have numbers in maybe different how do I put it? You have numbers in different bases, for instance. Let's just use that as an instance. You have numbers in different bases, then and those numbers are important. So let's say you have okay, you have a true or false in zeros and ones. Then you have maybe something like uh, you have then maybe you're getting a grade, for instance. You're getting a grade in maybe, so anything from 60, 0, anything from 39 is 1. That's for instance. So at times when working with that data, you might want to convert them to the ground level. So depending on the kind of analysis you are doing, you might put them on the same level, same base, for instance. Same base, for instance. So you'll be having maybe point, 0 0.d, 0 0.that, 0 0.d, 0 that, and all that. So all these things comes into play when you are working with data. For instance, so when you have them in that unified format, then you can make a particular kind of analysis on that. So you can say, okay, 0 0.1, 0 0.2, then you might be able to plot them on the same graph. It happens that way. When you're having 100, you're having 40, you're having 42, you're having that, then you want to compare it to a table that just consists of zeros and ones. So you maybe want to break your data down so that everything that you are plotting is in 0 to 1. It makes your graph look nicer, more presentable, and more reasonable. But once the scale is all over the place, you're always like, oh God, what do I want to do? Yeah, so data transformation is important. So in data mining, now all these steps has been carried out. So in data mining is process of analyzing data and finding patterns, correlations, and anomalies in the large data sets. So yeah, you've cleaned up the data, you've transformed the data. The next step is to check for patterns. You are like, all right, okay, with all this, what can I deduce from this information? What can I is there an increase? Is there a correlation, a positive correlation, a negative correlation? Is there an anomaly? You check for those things, then you make, and that will help you make an informed decision. So after doing all that, maybe you are trying to build a machine learning model. Data mining helps the machine learning process a lot, because you're only feeding it information. The machine learning systems help you to actually identify these patterns. At times when you maybe you're making use of at beginner's level, maybe you're making use of a random forest classifier, for instance. Now, if you feed in data that is not properly cleaned, the algorithm itself will try to make out find out a pattern from everything you're giving it. Okay, even if some information is not really important, there's so much noise, there's so much filth all over your information. At times, you just make a prediction that really makes no sense, because the algorithm is trying its best to, okay, I need to make a pattern, get a pattern. But once you are given it structured data, you are given it well cleaned data, well data that has been transformed, subjected to proper processes, then the machine learning algorithm gives what a better prediction on what you have done. It can get a pattern, help you predict a trend. So that's where all these data mining processes comes into play. So data from employee databases, financial information, vendor lists, customer accounts, etc. in this data set. So each data set can be manually, automatically explored using statistics, ML, and artificial intelligence. So yeah, pattern evaluation. Now, so you have um, found out the pattern, you want to evaluate the pattern. So okay, I have this pattern. Okay, what do I do? This is okay, this is interesting, this is not so interesting. You want to evaluate. So yeah, you can make your conclusion. You need to have a conclusion after doing all that. Okay, there's a conclusion. Okay, so this is the pattern we have gotten. This. So what do we do with that? So the next thing, final thing is you want to talk about knowledge presentation. Now, this step is very important. You want to have your analysis, your evaluation in a presentable manner. You have to tell them, you have to tell people that, okay, based on the analysis we just carried out, we found out that the amount of sales of this particular product correlates maybe with the time customers came in, for instance. So you can say this particular product, maybe people got it in this product had the highest sales over 5 years between May and August. Is there a particular reason? Yeah, maybe there's a particular reason. Maybe falls into the rainy season in Nigeria, for instance. So people actually purchase that product. So let me say you're selling a raincoat, for instance. So you can say, okay, the purchase of raincoats actually skyrocketed in between May and August, for instance. So I just an illustration. Now, at times you may not be able to show people all that complicated mathematics and all that. Okay, what's this? But with visualizations, when we talk about different visualizations, we're talking about graphical representation. So you have your bar charts, you have your histograms, you have your lines, you have your linear regressions, you have all those figures to help people understand, all right, okay, this is what you did, this is what you didn't do, this is what we discovered, and okay, this is what we are suggesting. It's a very important step in data mining. So we can look at this picture, we can see the data, and we can see the selected data, we can see the adjusted data under pre-processing. So in pre-processing, we're talking about data integration and data cleaning. Then we're seeing transformation, data mining, you can see the graphs and all that. Then evaluation and interpretation is where you talk about information knowledge. Now, some techniques used in data mining, and one very important thing you need to know is statistics. Statistics helps you a whole lot. You basically cannot make maybe pattern evaluation and all that without the help of statistics. Now, we know statistics in different ways. People don't just know it. So, for instance, someone that maybe does not have that statistical knowledge per se might say, there was an increase in this with this, but someone else might say, okay, there's a positive correlation between this and that. So we all make use of statistics all the time, or like basically all the time. The average marketer does that. So you can say, okay, this particular marketing strategy work, this marketing strategy work, and all that. So if you are a data scientist, data analyst, a machine learning engineer, generally, or you are looking to delve into the career, so you want to know statistics, you want to have knowledge of statistics, you want to study collection, analysis, interpretation, then presentation of data are all using statistical models. So when you hear bar charts, you hear pie charts, we all came across those things in high school. They are very important. Currently, you can use it in data mining. It helps your work a whole lot. It helps you, in fact, just having the knowledge alone makes you know how to select your data, makes you know what you need to do with your data. Without you just look at the data and you can tell, okay, this is this, this is that, I need to do this, I need to do that. So it helps a whole lot. I mean, you don't just have statistical knowledge, then you're just looking at the data and you're trying to understand what is going on. But with statistics knowledge, just looking at it, you know, all right, this is what I need to do. Now, for machine learning systems can be recognize those patterns for you. So right now, there are a lot of algorithms out there for you to use. So at times, you may not be able to build your own algorithm. Let's say you don't have the machine learning skill set, writing your own algorithm or writing your own classifier, for instance. But there are a whole lot of classifiers out there that can help you get patterns, make predictions, give you a metric score, give you an accuracy score, give you valid predictions. All you need to do is make sure your data are clean. So machine learning of various algorithms are useful to analyze, clean, and make predictions on those data for you. So there are all other lot of techniques out there, but I think statistics and machine learning really stand out in data mining. So some challenges that comes with data mining. So now, one thing is the methodology. Now, because the use of data varies, and there are various applications for data. So at times, the methodology that works for a particular kind, let's say kind of data, might not be so great for another kind of data. So there are a whole lot of tools, and each tools have as their strength. So for instance, let's say you're trying to scrape data from a website. Let's say that. So at times when you're making use of a library like Selenium and something like Beautiful Soup, they have different strengths. So when you talk about Selenium, Selenium is great for clicking. You want to click on a particular button, you want to click on that. It's so straightforward with Selenium. When you're using Beautiful Soup, you'll probably be writing a lot of for loops to achieve that same goal. And when it comes to accessing some other kind of data, you have a great advantage when using something like Beautiful Soup or Mechanical Soup. So what do people do? People mix them up. So you are able to use different scripting methods on the same data set. It just helps you. That's what I mean. So methodology at times with working with data, it can cause a constraint, especially when you don't have all the skills on it. So at times you might have to look up, okay, this is stressing me. Then you don't have maybe knowledge of maybe some another tool, or you don't even know it exists. You can get stuck on a particular tool and spend a whole lot of time on it. So at times, and newer tools are coming up to help you work with um, data more easily. So you just need to get updated. So that's one of the few things that can happen. Interactiveness. So your data has been successfully mined. Your data needs your predictions, your patterns, your conclusion needs to be interactive. Someone needs to understand what you did. Now, so that's where visualization comes into play. At times when people mess things up is you can't present your data is not presentable, or whatever you presented is not understandable, it looks all over the place. So that's one constraint that comes with data mining. So you need to find out a way to fix that up. So you want to make sure my data is expressive, it's clear. So once someone looks at the pie chart, it knows that, okay, this I can tell that, okay, there's an increase here, there's not an increase here, then maybe you just have to shed more light. But when you just present maybe a scatter diagram to someone that is not maybe mathematically inclined, it's all like, okay, what's going on? I'm just looking at dots, dots. Then you have to start doing a lot of explaining whereas you could have use another method. And at times, the scatter plot might just be the best that you can make use of. So it does vary. So at times, those things comes as constraints in data mining. So another thing you want to look at is there are various factors such as the cost of extracting information and pattern from databases. At times, it takes a lot of effort, a lot of money, to extract information. Even getting information at times might be tedious. At times, complex algorithms require expert resources, and which expert resources need to be applied. So at times, to make use of some algorithms, you need an expert. Sometimes the gap in skill sets just comes into play. Another thing is type of information. Now, historical data may not be the same as that which is in the present, so the analysis may not be useful. So at times, you're trying to make an analysis about something, and maybe you have information from 10 years back. There's a lot of things that happened, things has changed. So at times with historic data has been long outdated, it might not so much help. It might not give you great results. So I think this really stands out of a whole lot of challenges you can get with data mining, but it gets better actually. You don't need to get worried. Okay, I'm scared. No, don't do that. It gets better actually. So the more you work on the data, the more you take approaches, the better you get at working with these things and all of that. So it's great. Data mining is important. I hope you've been able to learn a few things from this little presentation. Have a great day. Thank you.